So 6.3 is trinomial squares, and I'm going to kind of do the same thing I did in section 2. I'm going to introduce what a trinomial square is, and then we're going to review the box, because it really doesn't matter if it's a difference of two squares, a trinomial square or not. The box is going to work, so we're going to stick with that box. If you choose to do FOIL, there is, or reverse FOIL, there is the video on FOIL, and I'm more than willing to sit with you and show you reverse FOIL if that's what you prefer. So let's move on with trinomial squares. So a trinomial square has two terms, and they are an a squared and a b squared. And it doesn't mean exactly a squared. It's a number squared and a b squared, so another number squared. It actually has three terms, but two of its terms are squares. Then you'll notice there's no minus sign or a negative in front of those two terms. The last thing is if you multiply the a times the b, not the a squared and not the b squared, a times b, and you double it, which remember that means multiply by 2, you get the very middle number of the equation, which is either going to be 2ab or negative 2ab. How does that look? Well, let's do this first number, and it happens to be a trinomial square. So this is x squared. This is 9, which is 3 squared. So the a is x and the b is 3, because this is the same thing as 3 squared. Well, a times b, so if it's x and 3, a times b would be 3x. If we now double it, 3x doubled would equal 6x. And you'll notice that's the middle number. Now, it's not a horribly important thing, but at least you're familiar with what a trinomial square is. There are different ways of factoring because they're a trinomial square. I just don't tend to use them. Let's move on to doing this problem. So I have two terms, and I know that means that I'm going to factor those using a box. I always want to check and make sure there's nothing I can take out of the terms, so I don't see anything I can take out of all of them. Remember that the first number goes in the first box, so x squared, and the last number goes in the last box, which is 9. So x squared, the only thing it is x times x, and 9 you have two things. You can do 3 times 3 or 9 times 1. Since it's all positive, no matter what, it's going to be a positive two numbers that you multiply there. I'm going to start with 3 and 3 and make sure, because that looks good to me. 3 plus 3 is 6, and 3 times 3 is 9, so I'm probably on the right track. Remember that this column all goes together. So this one's 3 and that one's 3. This column all goes together. So if this is x, this has to be x, so this is x. If this one's x, so is this one, and so is my row. And that leaves me here with this one. If this one's 3, so is this one, and this one's 3. So I get x plus 3, x plus 3, because the 3's are positive. So if you want to write the plus in there because they're positive, you see that they're a plus. Okay, so now we see that this is actually 3x, and this is 3x. And remember that if I'm adding these two together, I should get that middle one. So that means that my answer is x plus 3 times x plus 3. So let's review what we know about factoring already. We know that the first thing we got to do is see if there's anything we can take out of every single term. If not, then you move on. If you can, then you take that part out. In the second step, we count the number of terms. If there's 2 or 3 terms, we use the box method or the FOIL, the reverse FOIL, if you're using the reverse FOIL method. So we're going to keep coming back to this because we're going to be adding to it a little bit at a time, because that's not the only steps. So let's look at this problem. This problem is x squared minus 10x plus 25. So the first number goes in the first box. The last number goes in the last box. I know the only way I can get x squared is x times x. 25, 5 times 5, or 25 times 1. So I'm going to use 5 times 5 and see if it works. I look at that middle number. That middle number is only 10. That's pretty cool, because I know maybe if I add these together, I get the 10. But it's a negative 10. So now I have to think about what happens if it's negative. If this middle number is negative and this number is positive, then these two are going to both have to be negative. And you'll see that as we practice it over and over again. So we go this column, negative 5. This column, x. This row, these two are going to be x. If this one's negative 5, this one's negative 5. And now in this spot I put minus 5x and minus 5x, and you notice that when you add these two together you get negative 10x. So what I'm looking at is x minus 5, x minus 5. So our directions again are factor, and we're going to do a couple of factor problems together, and then you're going to start the assignment. So remember that the first thing you have to do is see if there's anything you can take out of it. And looking at these three terms, they are all they are all even numbers, which means I can divide every single one of them by 2. So I'm going to do that first. I'm going to say this is 2 times x squared minus 2 times 20x plus 2 times 100. So if I take that 2 out and set it aside, I'm left with x squared minus 20x plus 100. There's nothing else I can take out, so I'm going to count my terms. This term we're kind of done with as far as the answer goes, so we can even slide it off over here, and we know we're going to end up with something times something. So we look here, the very first, so there's 1, 2, 3 terms. I got to do a box. First one goes in the first box, last one goes in the last box. X squared, we know, is an x and an x. 100, we have several ways of doing it. Remember that you can do 10 times 10, 100 times 1. We can do 25 times 4. We can do 20 times 5. But look at 10 and 10. My middle is going to be negative 20. And if I make this a negative 10 times a negative 10, I get a positive 100. And if I add them together, I get a negative 20. So let's use negative 10 and negative 10. This column, negative 10. This row, x is here, so that must have been an x. Let's see, this row, if x is here, or this, pardon me, negative 10 is here, this is negative 10, and, oh, that's right, x here and here, this is x. So in this box, I get negative 10x. This is kind of like a check for me right now. We will be doing some checks in a minute, but right now we look at x minus 10, x minus 10, because we see here we get the negative 20x, x squared, and 100, so we know we've done that part right. So this is my answer. All right, so again, we're going to look and see if there's anything we can take out of all three of them. And I noticed that in all three terms, there is something common. What do you see in all three terms? You see an x. So this would be x times x squared, because remember, 2 bases with 2 exponents, because remember there's a 1 there, you add the exponents. Here, x times 24x, because I need 2 x's. And then x times 144, because I just need the 1. So that first x I'm going to put off to the side because I know it's going to be part of my answer. And we look at the rest of the problem, and we have x squared plus 24x plus 144. Is there anything else I can take out of all those terms? Not yet. Nothing I know of. So we're going to put an x squared here. First number goes here. Last number goes here. And remember, we took this x, set it off to the side because we know it'll be part of our answer, but it's not going to be part of our factoring. X squared, again, we know x squared has to be x times x. 144. Well, we know it's 144 times 1. There's probably a ton of things, but what I want you to look at right now is look at this middle number. The middle number is 24. What times what equals 144? But when you add it together, you get 24. Well, let's try 12 times 12. So in this column, we're going to say up 12, 12, 12. In this column, these are supposed to be the same, x, x, x. And this, well, this is an x, so this is an x. Boom. This is a 12, this is a 12. So we're looking at 12. In this, we have 12x and 12x. And when I add these two together, I get 24. So I know I have the right answer, x, and it's a positive 12, x plus 12, x plus 12. Now, it's not always going to come out where they're exactly the same. It's just the problems we're working on right now. Now, looking at this problem, we're going to start again with the first step. Is there anything we can take out? And at first glance, what do you think we can take out of all three terms? Well, we can't take 2 out because these two we could divide by 2, not this one. Can't take 5 out and divide these two by 5, but not this one. But will 3 work? Okay, so let's try 3. 3 times 16m squared plus 3 times 40mn plus 3 times, running out of room here, 15n, take that back, 25n gives us what we're looking for. So I'm going to set the 3 aside, and I've got 16m squared plus 40mn plus 25n. So we set the 3 aside, and we know we're going to have something times something. Everything's positive, so we don't have to worry about subtraction and anything. So the first one is 16m squared, and the second, or the last one, is 25n, and I think I forgot the square. I did. 25n squared. So I know that this is m times m. It's the 16 I have to think about. And the 16, to get 16, I know I have 1 times 16, 2 times 8, no 3, 4 times 4, and we know 5 doesn't work, 6, 7, 8, and we already have the 8. Let's look at 25. 25, 1 times 25, 5 times 5. That's all we've got. So I'm going to try the squares just to see if they work. So I'm going to say this is 4m and 4m, and this is 5n and 5n. And this column is going to get the 5n. This column gets the 4m. This row gets 4m. And this row gets 5n. And if we keep it like that, you keep it consistent, then it'll be easy for you to remember. Now, we've already changed this. We changed it to this. So this is the one we need to focus on. And the middle number is 40mn. So 20mn and 20mn makes 40mn. So it looks like we have 4m plus 5n. It's positive 5n. 4m plus 5n, because it's a positive 5n.